Epoch in software learning. Let us invoke God's blessings through prayer. Reading from the Holy Bible, Psalms chapter 69, verse 30. I will praise God's name in song and glorify him with thanksgiving. Heavenly Father, we praise and thank you for the abundant blessings upon us. We place this third day of faculty development program organized by our PG and Research Department of Mathematics in your mighty hands. Shower your richest blessings on our resource person, Dr. A. Salim Raja, and all the professors. Bless our e-learning platform and fill us with your Holy Spirit. We ask this prayer in the matchless name of our Lord Jesus Christ. Amen. Now, let me introduce our resource person. The only person who is educated is the one who has learned how to learn and change. I deem it a great pleasure to welcome and introduce Dr. A. Salim Raja, lecturer, Information Technology Department, University of Information Technology and Applied Sciences, China's Sultanate of Oman. Education is an effect of listening, which in turn leads to even better listening and attentiveness to the other person. Our resource person, Dr. A. Salim Raja, has completed his BSc Computer Science degree in HKRH College, Theni, MCA in RVS College of Engineering and Technology, Dindigul, MPhil in Periyar University, Salem, and PhD in Bharathidasan University, Trichy. Education is the most powerful weapon which you can use to change the world. Sir has 13 years of experience in teaching courses in both undergraduate and postgraduate levels and has published over 13 articles in peer-reviewed journals and conferences. He has trained project students in bachelor and master level in the field of web, mobile, and IoT application developments, Cisco networks, and Python data science. His keen interest in the subject and thirst for knowledge is worth mentioning and to be appreciated. Technology will not replace great teachers, but technology in the hands of great teachers can be transformational. Sir has organized practical workshops for students and teachers in reputed colleges. He has supervised more than 5 applied research journals projects in Oman. Sir's research interest includes machine learning, mobile computing, data mining, and cyber security, image processing. Sir has presented research papers in reputed international journals and conferences. He is the trainer on Cisco Internet of Things, data science and machine learning, mobile programming, big data, Cisco networks, and Python, and has received many professional certifications. In 2021, Microsoft has certified Azure AI Fundamentals as well as Microsoft Technology certified him as Associate Database Administration Fundamentals, Python and Java. In 2020, Cisco IoT Fundamental Connecting Things, Huawei certified ICT Associate and Academic Instructor, Cisco Networking Academy Instructor. In 2008, Cisco certified him as a Network Associate. We are much privileged to have such an eminent personality amidst us. I cordially welcome you, sir. I extend my heartfelt welcome to our dynamic head of the department, Dr. W. Rita, and all the professors from Holy Cross College and other institutions. Once again, I welcome one and all gathered in this virtual meet. Now, I hand over the session to Dr. A. Salim Raja, lecturer, Information Technology and Applied Sciences, China's Sultanate of Oman, on the topic, Basics of Machine Learning and its Applications. Over to you, sir.
Thank you, ma'am. Thanks for your introductions and the prayer.
Thank you, sir.
I personally thank the management, head of the department, and principal, sir, who arranged this kind of FTP program for the faculties. This will really fruitful to them, as well as we can share our ideas to our students too. So I will not take much time. I will directly move to our topic. My voice is audible, am I right, ma'am?
Yes, sir. You're audible.
Yes. Can you see my screen?
Yes, sir.
Yes. Okay.
It is visible, sir.
So today's our topic is basics of machine learning and its application. The contents are not much more because we have vast amount of contents, and as well as we have lot of algorithms and applications. So I just filter out some of the important basic algorithms and the methods how to proceed with your research. Okay. So in this background, I just organize my content like this. Okay. So initially we start with what is machine learning. So those who don't know about machine learning, so we can start with them. How machine learning works and applications, some of the applications, type of machine learning algorithms, and we have a small implementations. And finally, I just want to give some brief about data pre-processing and feature selections. Okay, this is more useful. The last part is more useful for them, those who do research, as well as those who are planning to applied research. They can use this idea. Okay, so we will move to the content. So as we all know, artificial intelligence, AI, dominate the world. AI is a broad spectrum. Inside the broad spectrum, we have different technologies combined together. Simply, we can say as artificial intelligence, but it has a lot of things inside. So one of the technology is machine learning. We can also have computer vision. We can also have robotics. We can also have IoT. So many technologies are hidden inside the umbrella artificial intelligence. So our topic, we have a machine learning only. So if we have time, we will discuss more about computer vision and robotics in upcoming sessions, right? So initially, the machine learning, what is machine learning? From the beginning, when computing technology come into the world, the scientists and the programmers and architects, everyone likes to create human-like intelligence to the machines. So it comes into the world in 1959, the term machine learning. Okay, so that from that point onwards, a lot of improvements happen in the world, programming side as well as the hardware side. So machine learning is the application of artificial intelligence which enables the software, the program, to learn from the experience and improve their self-task without being explicitly programmed. This is, we have to underline, explicitly programmed, because every one of us, we know how to do the program, because we basically learn the logics of program, and also we know how to create the logic with the background of mathematics, right? So the explicit program, basically what it contains, you can see here, the traditional explicit program which has a data, and we have the logic, that is a program, and we can able to produce the output. Whatever output we want, we can able to create the code or logic accordingly, and we have to feed the data, so the output we can get whatever we need. But what is machine learning here? The machine learning part, we are going to give same data, and we are not going to create a program. Instead of that, we have a model. For the model, we have to give output. What is the output? What are the outputs for every data? And the model which trained itself, and it will create a logic based on our data. Based on our data, it will create logic by itself. When new incidents or new data comes into the system, it will detect what is the reality of those data, whether it is accepted or not accepted. So it can able to understand the data, and it will work accordingly. That is the main difference between our traditional programming and machine learning. For example, computer vision, when you talk about computer vision, so normally when you give a picture to the system as a data, It can store in different format. So we can able to get what is the color of the picture, and we can able to get what is the size of the picture. This is normally we routine work we do. But when you come to computer vision, which inbuilt with machine learning, the concept, right? So it can able to understand what is inside the picture, whether it is a bird or road or car or street, what is inside. It can able to understand, and it can able to classify all those objects, so that we can able to extract some meaningful information from the picture. This is the major difference between traditional programming and machine learning. Okay, so next we move to how machine learning works. As I already said, we have to give data, and we have a model. We prepared a model which will accept the data which also gives the output. What are the outputs we have already? So it will train accordingly, and when new data or new incident happens, it can able to understand the data, and it will give, or it will work accordingly. Okay, so you can see here the picture. We have a set of fruits, different colors, different size of fruits we have. We have to give these details into the machine learning algorithm. It can train itself. It can train itself based on our data. Some data we have output, some data we don't have output. Okay, so it will train itself, and it can create a logic how to classify those fruits. Some are mangoes, some are bananas. It can able to classify by itself. Okay, so it trained itself. It automatically classify the fruits based on the size, color, nature of the fruits. You can ask the question, how can we give the fruits as an input to the machine? We cannot give fruits as an input to the machines. We have to extract the details of the fruits. For example, I have a fruits image. I can able to measure the size of the fruit, color of the fruit, and the flavors, or so many features we can able to extract from the fruits. Those are we called as a features or data. Okay, so those data we can give it as a file, okay, to the machine learning algorithm. It can able to train by itself. We are not giving any specific logic to classify it. We are not defining any rules, like if it is red color, you can define as apple. If it is yellow color, you can define as mango. We are not giving any rules. It will detect by itself. Okay, so this is the actual machine learning working pattern. Okay, so next is how to prepare our models. Okay, how to prepare our system. So we have to follow 7 steps in the machine learning. Okay, so first we have to gathering our data. Where we have to gather? This is the first question. Okay, so when you are working in a company, the data is already there. It is in different format. It may be in a text file, it may be in a database, it may be in an Excel file, it may be in different format. So you have to collect those data and integrate into one format. That is data gathering. And also you have to remove what are the unwanted data. Okay, so that is pre-processing. We will see at the later what we have to do for this. Okay, so data gathering. For example, I am going to do some research on about different kind of security attacks. So we have a explicit data available in different repository in the internet domains. So you have to download those data. Suppose I want to find what is the interesting pattern or the feedback about audience. Okay, so we have to read the data from Twitter. Yes, you can read live streaming data. You can also read, and you can prepare your data set. Okay, so our data set, we have to decide where we have to collect it. Okay, so next one, what we have to predict, or what we have to get the output. Based on that, we have to choose our model, because different algorithms are there. Every algorithm can be applied to different set of data. So you have to choose the proper algorithm, that is your model. Okay, So we will see what are the models available. And once you choose the model, you have to feed your data. So how to feed our data? We have to split our data into training data and testing data. So we have to split our data into two parts. Same data, we have to split into two. One is for training, another one is for testing. For example, I have 1,000 records, 700 records for training and 300 records for testing. You can ask the question why we have a 700 records for training and 300 records for testing. When you have more records for training, the system will automatically understand when the data is more, the predictions accuracy will be more. So we have to give more data, then the prediction accuracy will also improve. And next one is the tuning the model. So I'm not much focused on tuning the model because it depends on the platform, how you implement it. Because somebody, they prefer to use a Veka tool. Somebody, they prefer to use some Python programming. Somebody, they prefer to use R programming. Somebody, they like to use Java as a tool for processing. So based on their platform, okay, they can choose the tuning aspects. What is tuning aspect here? When you have a model, assume that it is a mathematical function or assume that it is a programming function, we have to pass some value to it. What are the values we can pass? Based on that, the model will prepare by itself. So those parameters, that is tuning parameters, we can able to give or we can able to use blindly. It depends on our need. Okay. So if you want to improve the accuracy or if you want to get better clarities, then you can give further attributes to the model. Okay. So the finally prediction, it depends on our objective. If we accept the prediction accuracy, okay, we can use it directly, deploy our system into the real world. So whatever, for example, if I want to detect what are the spam mails, okay, so Gmail, it is already having a mechanism to detect what are the mails are spam, what are the mails are not spam. So that is real implementation of machine learning. So the prediction accuracy, it can be improved or we can accept the accuracy whatever we received. Okay, suppose if you want to improve the accuracy, you have to just go back all the steps. You have to refine your data as well as you have to choose the proper model, and you can apply different tuning parameters, and you have to give more data to the training and you can test finally. Okay, so you have to refine. It depends on our expectation, right? That is a predictions finally, right? So these are the steps. Okay, so as I said already, the input, everyone, can you able to see my screen? Yes. Yes. Can you see my screen?
Yes, sir.
Okay.
It is visible, sir.
If any network issue happens, so I don't know, I just follow it. That's why I just check it. Okay. Okay, so we have a input data and we have a model. So the model gets trained based on our input data. So once we have a trained model, we can have that model. We can take it as a model. As a software programmer, we can see that once we perfectly test our software, we can make it as a exe file, executable file. So wherever we want, we can directly deploy our exe file, right? Same way, you can able to copy the model. Okay, so once you get a complete model, so you can take it as a model fully and you can test your data. Okay, so how much, what are the ways you want to test it? You can test it. Okay, and finally, the accuracy, you have to decide whether it is acceptable or not acceptable. Then you have to refine your previous steps. Okay, so what are the applications we have at present? Okay, there are many more applications. You can innovate many things. Okay, even for robot vision, or you can detect the corona, you can detect mask on the face. any kind of applications you can apply machine learning logic, because same like human thinking. Okay, suppose if you have some problem, you have to decide how to break out the problem, right? So you have to find some logic, and your brain uses the previous experience and previous things, and you can easily break the problems, and you can easily come out from that problem. Same thing. Okay, machine learning is same like creating a logic and choose the problem, and you can able to bring out the solutions. Okay, so here some of the application is face recognition and voice recognition. Still lot of things to improve face recognition and voice recognitions. We have a lot of research is going on to improve language wise, because language is very critical to process. When you written language is easily you can able to process it, but while speaking way, okay, so it may have different slang. So it's very difficult to understand human languages and to process it. Still we have to improve a lot. And healthcare industry, the prediction of disease, and what kind of medicines can be applied to, what kind of treatment can be given to the patients. Okay, so a lot of applications we have in healthcare industry. And we have a weather predictions, and we can apply this weather prediction along with the IoT. Okay, so we can combine, we can create innovative applications. And we also have many recommendation systems. Okay, even Facebook, Twitter, or any other shopping application, online shopping applications, we have a recommendations. Okay, proper recommendations that will increase the business and improve the profits, right? So that is very important for business board. Okay, so the recommendation system, even in the education sector also, what kind of teaching methodology we need to train our different categories of our students. Okay, so next one is the type of machine learning algorithms. Okay, machine learning models. When we come to here, so there are basically we have two categories. One is supervised and another one is unsupervised learning. In the supervised learning, we have two major subtopics, that is classification and regression. Unsupervised, we have a clustering and association analysis. Okay, so for classifications, we have categories. Classification, actually, we have a category, whether it is a red or black, whether we have a corona or not. So we have classes, different categorical data, okay, as the output. Okay, so that is classification. When you come to regression, it's a continuous data. It's a continuous data, real value it will come. So we can able to predict what will happen in near future. Based on our past data, we can able to predict what is the price of a particular place or particular flat or particular house. Okay, so we can able to predict what will happen in future. It's a real value. So it is obviously it's like numbers. Okay, but classification, when you take classification, it's a categorical. Okay, so categorical data. And we have a clustering here. Clustering, first two are the supervised one, and second two are the unsupervised one. I will tell you what is supervised and what is unsupervised. So clustering here, we can able to classify the items. We can able to classify the things based on the nature, inherent nature of the data. So it can understand by itself and be able to group the items. That is clustering. Association, it can able to find the strong relationship between the items. Okay, so that is association analysis. So next we'll come to what is supervised and unsupervised learning. Okay, the supervised learning is where you have an input variable X and the output variable Y. We have an algorithm, that is F, the function, which will map the X to Y, the output. Okay, for example, here we have a price of the flat. Okay, so price of a particular flat. Okay, so we have three 3,000 square feet, 3,125 square feet, 5 bedrooms, 3 bathrooms. The price is $5,30,000. Okay, so similarly, we have different data. So we want to find what is the price of the square feet, 3,950. Okay, so we can able to predict based on our past data. This is supervised learning because the output, when you see here, the price is the target. Okay, price is the target, and square feet, bedroom, bathrooms, all are input features. Okay, so input features, and the last one is the last column, which we have as a target column. Okay, so the features are independent features. Okay, and the target is a dependent feature. The target price is, it always depends on the independent features. Okay, square feet, bedrooms and bathrooms. Okay, so it based on the independent features. Okay, so next is we can able to predict the price. This is supervised learning because the output also we already know. Okay, so the previous data we have a independent feature, and also we have a target, and we have to predict some more new data. Okay, so new data we have to predict. Okay, this is supervised one. And unsupervised one, we don't have a targets, we don't have a the target feature. Okay, so we fully give as a data. So based on the data inherent features, we can able to group the data, group the items. Okay, for example, here we have a raw input data, so which we have different kind of fruits. We are not giving the labels. You can see this is apple or banana or mangoes. We are not giving any labels. Okay, so simply we are giving as an input, and the system will understand, depends on the nature of the data, and it can able to group the items. Okay, this is unsupervised. Okay, this is unsupervised learning, only having input data and no corresponding output variables. The goal of unsupervised learning is to model underlying structure. What is inherent feature of the data, so it can understand, and based on that, it has to classify or cluster the items. Okay. So next is data set. As I already said, when we have a data, so we have a set of features. You can see here. So here you can see date, customer, account, all are individual columns. Individual columns we can say as a features. Okay, so the complete row is a records, number of records we have to give. Okay, similarly for real world, any data processing, you have to process like this. Okay, so you have to prepare your data set. Okay, so the data set can be in a different format. You can use different format. It can be in a text file, it can be a CSV file, it can be a JSON file. Different file formats are there. You can prepare by which one is convenient to you. You can prepare it. Okay, so different columns, all the columns we can consider as a features. Okay, we can also have target. Okay, so we can also have target. So the target feature and normal features, or we can group into independent variables and dependent variables. Okay. So the data, usually we have a numerical data, and also we have a categorical data. So numerical data, we have a numbers, and categorical data, we have a strings. Okay, so that is the main difference. Depends on that, we have to choose our model. Okay, so depends on that, we have to choose our model. First one, when we go to the first one, regression. Here in a supervised learning, we have a first algorithm, that is a regression. Okay, so the regression algorithm, regression analysis is a form of predictive modeling. It can able to predict what will happen in near future, or we can able to find the progress. Okay, or we can able to find what is happening in the business, revenue. Okay, so we can able to analyze like this. Okay, so it can able to predict the data based on the independent and dependent features. Okay, based on the independent and dependent features, we can able to predict what will happen in near future. For example, here given different kind of accommodations. Okay, so price also there. So we have to find what is the price of some new buildings. Okay, so we can able to predict based on our previous data. Okay, so regression, we have two types of regressions. We have a linear regression and a logistic regression. I'm not going in detail about everything because I'm not much more expert in mathematics, so I just understand how it works, so I like to share with it. Okay, those who are expert in mathematics, especially statistics, you can have a great opportunity to explore many different algorithms and results. Okay, especially mathematics departments, you can combine with the IT departments, you can implement your new ideas, new innovative projects with the help of IT persons. Okay, so linear regression is a machine learning algorithm. Okay, so it usually predict numerical values. Okay, numerical value it will predict based on the dependent and independent features. Okay, so regression is performed when dependent variable is continuous data. Okay, as I said, it should be a continuous data, that is a real value, real numbers. Okay, numerical value. Okay, so the predicators, that is independent variables, it can be in anything. Okay, so it can be anything. That means you can convert into numerical form if you want, or you can process it based on the categorical data. Okay, and the simplest form of linear regression is, as we all know, the straight line equation. Okay, y equal to, it's not straight line equation, it's a line equation. Okay, based on the slope. Okay, so we can able to predict what will happen if x, any value changes in the x, we can able to predict what will be changes in the y. Okay, so we have a linear equations here. Okay, so this you already know, the basic linear equation that you already studied. M is a slope and c is the intercept. Okay, so based on that we can able to predict what will be the demand. Okay, what will be the target value that we need, we can able to predict. That is linear regressions. So linear regression, basically we have to find the best fit line which should minimize the error, which will cover all the data points, and the error rate should be minimum. Then we can choose that is the best fit line. Based on that we can able to predict our results. Okay, so we can able to draw many lines which will connect all the data points, but we have to choose the best fit line. Okay, based on the minimum error value, we have to choose the proper best fit line, so that we can, our predictions will not be missed. Okay, and next one is the classification. Okay, so the classification category, classifications, we can able to classify the item. We have a categorical data. We have to categorize whether it is a spam mail, whether it is not a spam mail, whether it is a corona patients or not infected. Okay, so we have to categorize it. Okay, so here we have a two class. One is the binary classification. Most of the problems are based on the binary classification, and some of the problems we have a multi-class classifier. Sometimes we have different classes, different groups. Okay, so we have to predict. Okay, for example, different colors. Okay, different types of flowers, different crops. Okay, different kind of trees, different kind of viruses. Okay, so we have to classify properly. Then we have to use a multi-class classifier. Okay, so binary classifier, we have two options. Okay, either male or female, or spam or not spam, positive or negative. Okay, so we have a two options. Multi-class means we have more than two options. Okay, and classification algorithm, we have a logistic regression, naive Bayes, and k nearest neighbor, support vector machines, and random forest. So you have to choose the proper classification model in order to train your data. Okay, so train your data, you have to choose it. So for that we have to understand what are the algorithm, how it works, what are the basic data requirements for particular algorithms. Okay, so all are mathematical based. Without mathematics, nothing in machine learning. Okay, so logistic regression is a special kind of linear regression. So linear regression, sometimes we cannot classify properly, so we have to go for logistic regression. So we have to use a logistic function. The logistic function we called as a sigmoid function. Basically, what will happen, it use log function which will string our prediction. For example, our prediction result, some discrete, some continuous value, it can able to string into a category like whether it is 1 or 0. Okay, so we can able to consume, we can able to concise our prediction value with the sigmoid function. We can able to classify whether it is 1 or 0. So, okay, so we have two data points. One is here, you can see in the picture, we have the bottom is a 0 and the top one is the 1. So when you draw the line, it will be like a sigmoid function. Okay, so it has two categories. So it will classify your data either in this category or that category. Okay, for example, we have a threshold value as 0.5. So based on the threshold value, it can able to classify whatever, for example, our prediction result is 0.6, then it will be 1. Okay, so if it is 0.4, less than 0.5, then it will be categorized to 0. Okay, that is the work of sigmoid function. Okay, so we have a logistic regression. When you have a linear regression, when you apply multiple linear regression into sigmoid function, we can able to concise our prediction into 0 or 1, that category. Okay, so next one is the naive Bayes algorithm. So naive Bayes is a probability. Okay, we can have a probability of happening the events. Okay, we can able to predict it. Naive Bayes is a powerful supervised machine learning algorithm which is used for classification problem. So it uses the target. Target is a predicted feature. Prediction feature. Okay, so that is a target variable. Naive Bayes assumes that. Please be clear. Okay, so naive Bayes assumes that all the independent features are independent. Okay, so we have a features and we have a target variables. Okay, naive Bayes, if you try to use naive Bayes, all the features are independent features. Okay, remember, there is no correlation between all those features. Okay, so then your model predictions will be good. Okay, no correlation between the feature, that is very important. You have to check before you feed your data. Okay, so Bayes theorem, we have a conditional probability. We have to check the conditional probability of events. Okay, for example, we have a data. So we have a car, different types of car, and the color types and the origin. Okay, whether it is stolen or not. Okay, so we have to predict. So based on the data, we have to predict. So first we have to build a frequency table and likelihood table. Okay, so here we have a color. First event is a color. Color, we have two different colors, red and yellow. So red and yellow, we have two options, either it is stolen or not. So we have to find frequency and we have to calculate this frequency and we have to find the probability of yes, probability of no. Okay, similarly, we have to take another feature type and we have to take another feature origin. Okay, so we have to find its probability. Finally, you can able to predict. You can able to predict whether the car is stolen or not. Okay, so we can able to predict. I just yes, here. Sorry, that slide is missing. Okay, so finally you can able to apply conditional probability. You can able to predict whether the car is stolen or not. Okay, so here next one is the k nearest neighbor. Okay, so the k nearest neighbor is one of the simple algorithm, machine learning algorithm. It can able to find the distance between two different classes. Okay, two different classes of data. Okay, already we have, and based on the data, we can able to find. Suppose new data is coming, it has to find the distance between all the previous data. Okay, then it can able to classify whether it is a category A or category B. Okay, you can see the picture. It will find the distance between the data points. Okay, so KNN algorithm assumes the similarity between new case data and available cases, and it can able to find whether which category it belongs to. Okay, and especially k nearest neighbor. it is a lazy learner algorithm. It will not learn before it predicts. Okay, so it will learn at the time of prediction only. Okay, so you have to apply KNN in a suitable application only. Okay, so here we have some data points here. Okay, so we have sports as the target, and we have some features here, name, gender, age. So first we have to find Silpa. Okay, so female, age is 5, whether she will like cricket or basketball or neither. Okay, so 3 choices we have. So we have a K is a the variable we choose. Okay, so the target. Okay, so the target, we have 3 different classes, so we have to choose the K. Okay, so we have to find the distance between every values. We have to find distance, the distance between every values here, gender and age we have to find. And once we find the distance between all the data points, we can able to choose 3 smallest value. Okay, 3 smallest value, and we have to decide based on the majority. Okay, for example, here the distances are computed. Okay, Ashok with Silpa and Ashok, we have a distance 27. Shilpa and Lavanya, we have 35. Like this, every data we have to compute the distance based on Euclidean distance. You can also apply different distance measures. Okay, so Euclidean is the basic distance measure. You can also apply different distance measure based on your data need. Okay, and we can able to find the distance. Okay, then we have to choose, because our K is 3, we have to choose 3 best smallest values. Here Diana, the distance is 9, Prasanna distance is 10, and some other distance is 10.05. So we have to choose these 3, and among these 3 data, 2 are cricket. So the output obviously is a cricket. Okay, so based on that it will predict. Okay, so next one is the support vector. I'm not going in detail about every algorithm, because you have to learn every algorithm. You have to, what are the parameters we have to apply, what are the restrictions we have, and where we can apply the particular algorithm, what kind of data requirements we need, how to pre-process all those data. You have to definitely learn. Okay, so you may think about what is the difference between data science and machine learning. Okay, data science is mainly used for prepare your data. Okay, machine learning is completely statistical model. Okay, so we have to apply some mathematical formula in order to predict, or in order to classify, or in order to group the items. Okay, support vector machine, again, it's a classification model. It also used for regression. Okay, so we have to find the hyperplane. Okay, so you can see the diagram. We have a 2 set of data. In the set of data, we have a separate line, a particular line that is we consider as a hyperplane. The hyperplane, it must have a proper enough maximum distance between hyperplane and the data point. Okay, once you choose the proper hyperplane, okay, your classification will be perfect. Otherwise, if you choose wrong hyperplane, then the classification, sometimes the accuracy will be there. Okay, next one is the random forest. The random forest is based on the decision tree. Okay, decision tree, we all know we have a if else conditions. We have to start from the root, and we have to classify. We have to go in deep by applying different rules, checking different rules. Okay, finally at the last we will get the results, right? So decision tree, based on the decision tree, the random forest will work. Okay, so for example, how random forest is giving results, it will generate set of decision trees based on your data samples. For example, I have 1,000 records. It will take 1,000 out of 1,000 records. It will take 200 records to build one decision tree. In the 1,000 records, we may have 15 features. 15 columns. Okay. So out of 15 columns, it may select 10. It may select 7 to build a decision tree. That is one model. And another model, it will create different features and different set of records. Likewise, it will create n number of decision trees. It will create n number of decision tree. Finally, it will sum up the result. What is the result of every decision tree? Finally, it will accumulate the final results. It can be an average or it can be a majority. Okay, for example, majority, what is the output? We can accept. For example, if you go and ask, suppose I want to buy a new bike. Okay, so I have to consult different, I have to consult my friends and neighbors and experts, so many persons, right? So they have different opinion about particular bike. Okay, finally, I have to decide. How I can decide based on the features and based on the majority opinion, I can able to decide which one is the right one for us, right? Same way here, the system will create different decision tree. At the end, it will consolidate the results. It can be an average or it can be a majority value. Okay. Next one is the unsupervised learning. So we have two different models. One is the clustering, another one is the association analysis. Okay, as I already said, there is no label for unsupervised learning. Okay, there is no target column. So you have to find what is the inherent features. For example, if you go to the class and there is an instruction to you, you have to group the students. Okay, you don't know what level they are, what category they are, nothing. Okay, so you have to group means we have to group the students based on the height, based on the age. Okay, so we have to do something like, right? So same way, the algorithm also find the inherent feature of the data and group it. That is clustering. And association, it mainly understand the relation between the features. Okay, what are the important features? They combinedly comes more frequently. So that will be predicted with help of association analysis. Okay. So clusters basically it has to group collection of data points. Okay, similar data points are into one group. Okay, another group, it has different set of data points that is dissimilar between a group, and another groups are totally dissimilar. Okay, different clustering algorithms are there. First one is the k-means density based and hierarchical clustering. Okay, so here I will show you the basic one, that is k-means clustering. You can have different medioid clustering, and many clustering models are there you can explore. Okay, so here I will show you the basic k-means clustering. K-means clustering is an iterative model. Okay, so we have to iterate till we reach the endpoints. Okay, the simplest model. Okay, so you can see here we have a data x1 and x2. So we have to find the distance between the data. So we have to choose the k, the centroid. We have to choose the centroid here. So we can randomly choose any 2 points as a centroid. Okay, or we have to apply some logic to choose the centroid automatically. Okay, because the main problem in k-means is who will choose the centroid. Okay, so you can choose, or you can build a logic to choose automatically. Okay, so here I choose 2 data points. Okay, randomly. Okay, then we have to go for step 2 to find the distance between points. Okay, then we have to build a table. Okay, so the table, every points we have to measure the distance from v1. V1 is our first centroid and v2 is our second centroid. We have to find the distance, and once we find the distance, we can able to assign which category it belongs, whether it is a v1, it's near to v1, or it's near to v2. Okay, so once we get it, we have to iterately do it, repeatedly we have to do it. Okay, so till when we have to reach our end, so either we have to get same cluster or we have to cluster elements. Okay, so we have to go till we have to get the same cluster elements. Okay, or get the same number of clusters. Okay, so next one is the association rule analysis. It can able to find the association between the items. every columns we have different items, so we can able to find the association between the items. So here there are two important parameters, that is support and confidence. The support, it points out how frequently the particular items comes. The confidence, it will say how confidently it must all the particular items are combined. So we have a confidence on the rules. Okay, so that can be found with the help of confidence. Okay. And here is an example, the basic example. This we already know because data mining. This is the basic model. Okay, so we have different set of transaction. Every transaction we have number of items that is purchased. A, B are different items. Okay, when you go on shopping, you may purchase different items. So every transaction we have a set of items. We have to find what are the items frequently seen. Okay. So we have to go step by step. First, we have to find how many items are there and what are the frequency support count. Okay. So before we begin our task, we have to set what is our minimum support and what is the minimum confidence level. So this we have to set by ourselves. We can set minimum support is 3. We can set minimum support is 4. It depends on our need. Okay. So we have to set it. So once we have individual items, and then we have to create a combined items A and B. Okay, then we have to remove what are the items which is not matching our minimum support count. Okay, so here in the first one, minimum support count is 2. So what are the items that matches 2 and above, it will be accepted, and what are the items less than 2, it will be removed. You can see here A, B, C, D will be there and E will be removed. And the next round, when you go to the next round, all the A, B, C, D will be there. We have to combine it, A, B, A, C, A, D. Okay, what is the possible frequencies? And here also we have to remove the item which is not frequently come. That means the minimum support, it will not match the minimum support. Then it will be removed. AD will be removed, CD will be removed. Okay, and finally we have to combine 3 items. What are the frequencies for that? Then we'll remove which is not matching our minimum support. Okay, so that will be removed. Okay, so similarly, so finally we will get ABC as the last one, 3 item counts. Okay, so the ABC is most frequently coming. Okay, so ABC is most frequently coming, and we have to find what is the strong association, strong bond between ABC. Okay, so here we have to apply confidence rule. So we have to find which is you can see A, B along with C, it has 50% confidence. Okay, and association between C, when those purchasing C, when you combine with the A, B, we have less frequency. Okay, so we have to find the support count. Okay, so the confidence rules that will decide how strongly it is associated. Okay, so next one, how to implement all those models. Okay, so far we discussed different algorithms. You maybe get bored because already you know all those algorithms, right? Anyway, just I revised it. Okay, next is how to implement this algorithm. Okay, so how to make it as a proper model, how to test our new research data. So we have to prepare our system. What are the softwares we require? Okay, so for that we need to install Anaconda. Okay, so Anaconda, there is a special package you have to include, that is scikit-learn. This is for Python library. Okay, I will go to here. So scikit-learn is a package, okay, especially for machine learning. It has inbuilt all the algorithms. So you can use scikit-learn for all kind of machine learning analysis. Okay. But sometimes we need additional packages. Like, for example, if I want to use image processing, then I can also combine, I can add some more packages like scikit image, or I can use OpenCV, or any other packages that you need, you can add it along with that. Okay. But the basic data processing and machine learning, scikit-learn package is enough. Okay. So it has many statistical models inside, so you can explore and you can test your data. Okay, first one, you have to install Anaconda. Anaconda is IDE. Okay, so you can test your programs, Python programs, with the help of Anaconda. So here I'm using Jupyter Notebook. You can also use different tools along with Anaconda. You can use it, but I prefer to use Jupyter because of the simplicity. Okay. Next one is the Pandas. Pandas mainly for data processing. Okay, so you can able to convert your data into 2D models, so that if it is like array, okay, if it is like 2D array, you can easily process. You can have rows and columns. You can able to plot your data. You can modify. You can delete. You can do whatever process that you want. Okay, so Pandas is the basic package in the Python. It will help to convert our data into 1D array, that means one-dimensional array or two-dimensional array. Okay, so if you have one-dimensional array, we have the name series, and if you have two-dimensional array, we have a data frame. Okay, and first one, how to process your data. How to process your data. So if you know already Python, it is very simple to implement your machine learning. Otherwise, you have to learn Python, how to do the basic coding, and then you have to come into machine learning. Okay, my suggestion is better you go with your first basic Python, learn the Python, then how to use functions, packages, and everything. Then you can come to data science, basic data science functions, and then you can come to machine learning. It will be best. Okay, because sometimes you may need different functions. If you have previous knowledge on data science and basic Python coding, that will help you to implement quickly. Otherwise, you have to refer, and you can find, you have to struggle to match your data. So it will take time. So my suggestion is learn Python, learn data science, not in deep, at least how to do this. Then you can come to machine learning. Okay, so first one, the data, I just explain the statements. First one, I just import the packages. What are the packages that I need? First one is the Pandas. Second one is the sklearn. Okay, so different packages I imported here in my program. Next one, I have to choose my data, where I have my data. Okay, so here I choose my data. The data is iris data. So iris data is, it's typically data about a flower. Okay, data about iris flower. Okay, so it has a different sepal and petal length and width. That are the features. Based on the features, we have to classify the iris flower. Okay, so different classes of iris flowers. So we have to classify them with the help of these data. Okay, so I will show you the actual data. Then you can see. First, you have to understand all the lines. Okay, that's why I explain all that. Okay, so once you have data, and you have to read it as a CSV file. CSV means comma separated values. So same like our text file, same like our Excel file. Okay, so it's like an Excel file, but we save it as CSV. Okay, so once you have a data, you can able to check the data, whether the data is available. Okay, because the data, it has to come into your data set. Okay, and we have to describe what are the mean and standard deviation, all the things we can get by the help of describe, and we can able to group the data with the help of group by. Okay, so once you have this, you can get the results like this. Okay, so we can test our data. What are the data available? Sepal length, sepal width, petal length, petal width, and finally we have a class iris setosa. Okay, there are many classes there. I will show you all the classes. Okay, and this is for print dataset dot head. Okay, that is the output. And dataset dot describe. You can see here what is the mean, count, standard deviation, minimum, 25%, 50%. Okay, so what is the average? Okay, so everything we can get with the help of describe. And what are the classes we have? What are the classes? The last column. Okay, the class. Okay, so different target variable is that. Okay, so iris setosa, iris versicolor, and iris virginica. Okay, so different categories of flowers there. Every category we have 50 records are there. Okay, so totally 150 records are there. Okay, so there are 5 columns and 150 records. Okay, so next our task is, once you load our data, next our task is to split your data into training and testing. Okay, so you have to split your data into training and testing. For that, we have to convert your data set into array. Okay, so array X and Y. X and Y, you have to separate your features. Okay, what are the features here? We have sepal length, sepal width, petal length, petal width. These are the features that should be in X. What is there in Y? We have a class. Last column is a class that will be in the Y. So you have to separate it. Once you have separation, then you have a built-in function training test split. Okay, train test split function, what it will do, it will split our data, X and Y, both data it will split. How it will split? Here we give a percentage, 20%. That means 80% is for training and 20% for testing. Okay, so 80% of our data will be for training and 20% of data for testing. Okay, so we split it. That's why we have to print it here. What is the size of the training data? What is the size of the testing data? Okay, so training data, you can see X train, X test. Okay, so we have 120 and 30 records. Every records we have 4 columns. But when you come to Y train, Y test means there is a last column, class. Okay, so it has 120 records, but there is 1 column. There is no number of columns. Okay, and 30 for testing. Okay, so once you have test and train and test split, you can apply your, you can train your models. You can choose your model and you can train. So here I choose logistic regression. Okay, so here I apply X train and Y train. Okay, for training my model. Okay, so logistic regression is the algorithm. Okay, so that algorithm I have to train it with the help of training data. That means features, 70% of features, independent features, and target we have a class. Okay, so that should be given. So X train and Y train, that should be given for training. Okay, once your model get trained, you can go for testing. So here I am giving X test. Okay, X test, we have to give random data. Okay, random data. So it will predict whether it is, I mean, it will check. Once the prediction, all the predictions will come, it will find the accuracy. Okay, we have an accuracy score with the help of Y test. Y test is already, we have a actual data and prediction. We have both will be compared and it will give the result, accuracy result. Okay, so next one, you can also use naive Bayes algorithm. Okay, so Gaussian naive Bayes algorithm here I used. You can use different naive Bayes algorithm. It depends on your need and you can check your prediction. You can see here logistic regression, it gives the prediction about 0.83. Right? That means 83% accuracy in our model. And Gaussian, when you check it, it gives 96% accuracy. Okay, so this accuracy may vary when you run different times with a different set of data. It may vary. So you have to run 10 times, 100 times, and finally you have to get the average accuracy. Okay. You can also use KNN. You can also use SVC. You can also use a random forest. Okay, so instead of model here, okay, so the model equal logistic regression model equal Gaussian naive Bayes. In that place, if you use SVC, if you use random forest, the accuracy, the algorithm, everything will be changed. Okay. So accuracy, when you come to accuracy, we can just get the accuracy alone, or we can get the confusion matrix, which will give how much positive and negative results that we get. Okay. So you can see here, this is our accuracy results. Okay. So this is the confusion matrix, which gives precision, recall, F1 score. Okay, I left this. What is precision, recall, F1 score? All are, you have to just refer. In scikit-learn, you will get more idea about all these parameters. Okay, mainly I just focus on the accuracy. The remaining parameter, different kind of results we have. So depends on your need. You have to choose which one you want. Okay. So what is precision, what is recall, what is F1 score? Okay, so that is a description given here. Before that, you have to understand the confusion matrix. Okay, so positive and negative, how much prediction accuracy, true positive and negative. Okay, so what is true positive here? Prediction is correct. Okay, False positive, that means prediction is wrong, actual value is positive. Actual value is positive, but prediction is negative. Okay, that is why false positive. Similarly, we have true negative, we have a false negative. So what is the ratio between that? That will be the accuracy. Okay, true positive and true negative, divide by true positive, false positive, true negative, and false negative. Okay, so when you divide it, you will get the accuracy. Okay, so next one, data pre-processing. Okay, so why we need to pre-process our data? Okay, basically, when you have a real model data, okay, it has different scalings. Sometimes some column it has a range 1000 to 10,000. I mean, the value will be in the range 1000 to 10,000. Some columns it has 0 to 1. Some columns it may have different ranges. Okay, so you have to combine into one model. I mean, one pattern. Okay, so for that we have to use feature scaling. Okay, feature scaling, we have different scaling methods are there. We have a min-max normalization and standardizations. We have using the standard formula, we can able to normalize our data. We can able to normalize our data, so it will be in one range. For example, it will be 0 to 1 or it will be 1 to 10. So you can able to confine your data in particular range in all the columns, so that your accuracy will be improved, your model training will be improved. Okay, so feature scaling will be very important for your pre-processing step. Okay, so how to do this minimax scaler? Okay, so when you have a data, you have to split x and y. After x and y, you have to normalize it. Okay, and here we have the result normalized data. You can see here previously before normalization when you print it. Okay, this is for medical data. Okay, so the medical data we have, you can see the first column. Okay, P register. Okay, patient register. We have different values. The values range from 1 to maybe 10. Another column we have a plasma, right? We have a different values. Okay, similarly third column you have different range. So if the data in different range and different format, your training will be it will take time and accuracy will also affect it. So in order to confine it, we have to in one format. Okay, so we apply max min, so all the columns will be in a one format. Okay, it will be in a range 1 to 0, 0 to 1. Okay, so in that range, so training will be much quicker and result accuracy will also improve. Okay, another one is the standardization. So standard scaler, how to do this? This is also given here, and you can see the results. Okay, before applying standardization, after applying standardization. Okay, and next one is this is for numerical data. You can ask what about categorical data? Sometimes we may have address, sometimes we may have male female, sometimes we may have different string data also. So in that case we have to convert your string data into numbers, because all our algorithms are based on mathematical formulas. So in mathematical formula we need numerical values. So we have to convert our string data into numbers. For example, if we have male female, you have to give male as 1, female as 0, or male is 0, female is 1. So you can give like that. Similarly, if you have different colors, red, green, blue, different data available in one columns, then you have to give different numbers for each type of data. Okay, so that is important. That is called for encoding. Categorical data, we have to do encoding. There are two types of encoding we have. One is ordinal encoding or label encoding, and another one is one-hot encoding. Okay, in Python we have a built-in function. No need to struggle. Just use that function. It will change everything. You can see, very simple. Okay, it is not much difficult. You can see here we have a data. Okay, so we have a data. You can see on the top right. You can see we have two columns. One is the norm 0 and RD2. Okay, so we have a categorical data. Okay, so in the categorical data, when you apply ordinal encoding, you can see the yellow color, the two lines. That's it. Which column you want to change, that column you have to give. Automatically it will assign numbers to it. Similarly, when you have a label encoder, instead of ordinal encoder, you can also use label encoder. it will give numbers automatically. Numbers will be given for every classes in the target, your particular column. Okay. And one hot encoding, it also changed, because one hot encoding, it is much better than, sometimes it is much better than others. You can see here, instead of changing the particular column, okay, it will create a newer column. Okay, for every categorical data in the particular column, it will create a new column. Okay, for example, I'm creating a new column for every value in every new, different value in norm column. Okay, NOM_0. That column, I have a different values: red, blue, green. For red, blue, green, I'm creating a new column 0, 1, 2. Okay, so 0, 1, 2, 0 is for red, 1 is for blue, and the another one is for green. Okay, so if there is a red, it will be 1. If there is a blue, the particular column will be 1. If there is a green, the particular column will be 1. Otherwise, it will be 0. Okay, so likewise, it will create a newer column. Once it is created, you can remove the particular column from your data set, and you can train your data. Very simple. Okay, Python, and the coding length is very, very compact, and you can do whatever you want. Okay, and next one is the feature selection. Okay, this is very important. Okay, how to choose the feature, because data is vast. Okay, when you do real-time data processing, number of columns will be more, and you have to confine. If you give more number of columns, then the processing time will also increase, and you will not give accurate results. So you have to choose the proper features. Okay, so for that we have to use feature engineering. Okay, feature engineering, you have to choose the correct, exact needed features. Okay, so that will improve your machine learning algorithm, that will reduce the complexity, your model will be more sensible. Okay, so you can avoid overfitting data. So everything you can do. You can see here, we have initially 7 columns, F1 to F7 columns. But after we reduce it, we can have a confined, we have only F1, F2, F3. All the remaining columns are not required, so we remove it. Okay, so how to decide it? Which column is required, which column is not required, how we can decide? We have some methods. Okay, so we have some methods. I'm not going in detail about these methods. I just pointed out all these methods are available, so you can apply before you process your data. So feature selection, we have a different methods: filter method, wrapper method, embedded method. Filter method, we have information gaining and chi-square method and correlation coefficient. Okay, and wrapper methods, we have a recursive elimination, forward selection, backward selection, and lasso regularization on embedded method. Okay, so first one, filter method. So here we have to find how much it is associated with the target. We have to select every column, we have to select every feature, and we have to find the relationship between the target. Okay, if you have a target column, so you have to find the relationship between your feature and your target. Okay, so if the entropy, that means the randomness of the particular feature is less, then information gaining is more. If the randomness is more, then automatically it will be removed. The particular feature will be removed from your data. Okay, so chi-square, it will detect how much, how related target and the feature. Okay, so we have to chi-square method, and also we have to correlation. Okay, so we can able to find Pearson correlation, and many correlation methods are there. You can apply any correlation methods to find the relationship between the target and the feature. For example, if you select one column, you have to make sure that column is fully, highly correlated with the target. So then you can choose that feature. Otherwise, you can remove that feature. Okay, particular column, particular feature is not more contributed to the target, then no need to use that particular feature, right? So, and make sure all the independent features are independent. Okay, if there is any correlation, because for example, first column and second column are more correlated, then you can use one column. Instead of using 2 columns, you can use 1 column, right? So the independent features are independent, and you have to find every independent feature must be correlated with the target class. Okay, so that's it. If you have any more questions, you can ask. I think we have time to discuss, right?
Dear participants, if you have any doubts, any queries, you can post it in the chat box. Sir, is there any questions? Dear participants, is there any questions? You can post your queries in the chat box. Or unmute your audio and ask the queries. Sir, what is the difference between machine learning, artificial intelligence, and deep learning?
Yes, ma'am. Actually, when we begin our topic, AI is the broad spectrum. Okay. So it's not a single technology to learn about AI. AI, which includes machine learning, which includes data mining, which includes your image processing. It combines all the technology into one umbrella. Okay. So AI is a general term. So AI, you can implement AI concept in different ways. For example, if you create a robot can do some limited task. It can able to think to complete a particular task. So in that way, you have to refine your, AI concept, right? Similarly, when you come for deep learning, here we have a neural network pattern. Okay, the basic model is neural network pattern. So the results are confined into one particular, one particular class. Okay, so that is deep learning. Deep learning is a sub part of machine learning. Okay, so here we use the same model, but we use neural network.
Thank you, sir. Can you run the program and show us live demo for machine learning?
Yes. So here, as I said, we have a different. Can you see my screen, or I have to just share my screen? Okay, can you see my screen? Yes.
Yes, sir.
Okay. So here I use Jupyter notebook. Okay, so you must install Anaconda. Okay, so you have to install Anaconda. So once you have Anaconda, you have different tools to do the programs. So here I use Anaconda. Jupyter. Okay, so the Jupyter notebook, it will start like this. We have all the folders. Okay, so it will show all the folders. You have to create your own folder where you want to store all your files. Okay, once you have a folder, here I have a folder. So on my documents, okay, so I have a folder. Okay, one folder for data and another folder for another one for my practice programs. Okay, so here I have my program file. Okay, here I have my data file. Okay, so here when I click this, it will open my Jupyter notebook. So here I gave all the different algorithms. Okay, different algorithms to implement. Okay, so this is for reference, not for running the program. Okay, so whenever we need whatever algorithm we need, we have to use that models. Okay, particular package, right? So here the first part. Okay, so we have a data. So where we have a data and what are the features we have. Okay, there are 4 features for independent features and one is for target feature. And here just maximize it so that you can able to see. Okay, So next one, you have to read the data. That means all your data into our program. So it will be in a variable data set. Okay, once you have data sets, you can able to see what are the data available. Okay, and this is your describe. When you give describe, this is the result of describe function. And group by, so you can able to group by your data based on the target class. Okay, target class. So we have 50 records for iris setosa, versicolor and virginica, separate 50 records, totally 150 records. Once you have a data, for example this code, okay, so when I finish this code, I want to test it, just click run, it will show you the results. Okay, so you can see here it is running. So here also you can see the star means it is still running, so you have to wait for the results. Okay.
Yes, sir. From the participant K. Dhanalakshmi, sir, what are the recent developments in machine learning?
Sure, I will explain. Okay, so this is for data loading, and next one is here we have to training and testing split. Okay, we can able to split our more data. Okay, so run. So when I give run, so training testing is finished, then you can come to the actual model. Here logistic regression, and finally you have to train your data, train your model, then you can use prediction. Okay, so then you can predict your data. Okay, so we can able to predict it. Okay, so finally you will get confusion matrix if you want, or just want the accuracy, you can use this function to get the accuracy. Okay, so here we have accuracy, and this is our confusion matrix. Okay, so when you run it, you can see when I run it, so you can get your accuracy. Okay, and you can also test, you can take some sample, any one row as a data, and you can test it. Okay, whether it is predicted correctly or not, you can test it. That is also possible. So for that also here I'm. Okay, so you can take any one row of data and you can test it, whether it will predict, your model is predicting correctly or not, you can able to test it. Okay, so here our data is available. Okay, so here I choose one column. Okay, first column, second column, third column, fourth column. 4 columns are given. So we have to test. Actually, I'm choosing iris versicolor. It will also predict same IC versicolor. Okay, iris versicolor. So prediction accuracy is correct. Okay, and naive Bayes. You can also use naive Bayes algorithm for classification. Okay, that accuracy also you can measure. Okay, different algorithms you can use. Okay, next I will come to the question. What are the recent developments in machine learning? Okay,
Yes, sir.
AI still moving forward. So AI basically it will mimic like a brain. Okay, so try to make machine is thinking like a human. Okay, so if it think like a human, then it can replace anyone. That is the ultimate end. Okay, so for that we progress slowly towards the same like human intelligence. Okay, better than human intelligence. Okay, recently the machine learning and IoT, it creates different kind of products. Okay, for example, you have a Google. Okay, Google, we have a hi Google. Okay, what is the temperature of today? You will get temperature. Okay, how it can works? Okay, it based on our language understanding, right? So it is also we have a machine learning algorithm behind, and it will get results quickly, right? And also we have an antivirus. Okay, so we install antivirus software in our machine. So it will check your every software and easily classify which one is virus, which one is not virus. Okay, so it is also machine learning algorithm. Okay, so every aspect in our life, there is some machine learning concept running behind. Either we know or not know, we are using it. Any more questions, ma'am?
Yes, sir. From Aishwarya, can you suggest any basic books for machine learning for the beginners?
Actually, I will give my PPT fully to you. Okay, so every topic I gave some specific reference. Okay, you can use that. Okay, because I refer many books which is more simple to the students. That book I just refer it here. Okay, so whatever reference I'm giving in every slide, because I'm not creating the content. It is already there. I just use it. So I gave the reference. Okay, so you can use that one. It will be more useful to you to learn from the basic.
Sir, another question, sir.
Yes.
How is machine learning used in digital marketing?
Digital marketing, especially to classify the customer, to attract, promote the products. Okay, so in that aspect, you have to go for sentiment analysis. Okay, so what is the sentiment, feeling of the particular product, or what is the people preference based on the feedback that is given in the social media. So you have to take those data, social media data, and analyze it, and you can better target your customer.
Yes, sir. From the Bridget Gladys, how is automation different from machine learning?
Automation, actually, it's part of AI. Okay, so we cannot fully automate anything. We can achieve some extent with the help of machine learning. Okay, so automation, it has to understand and perform the task by automatic with the help of basic machine learning algorithms.
Okay, sir. Can the mathematics students get into the field of machine learning after their graduation, sir?
Of course, ma'am, because it's fully based on the mathematics. So students may basically, what is the problem? No, mathematics students, they are not much interested on programming. Programming students not focused on mathematics. If they combine together, for example, if they are doing project, they combine together means really they will innovate new things. Because the understanding level of mathematics teacher and the understanding level of IT teachers are different. So when they combine, usually in abroad, all the university, they have combined mathematics and IT together, even in my university also. So we frequently, suppose if I want particular, actually when I start learning machine learning, I want to do some application, but I want to find what are the features are important for my target class. I don't know what algorithm I have to use. Then I ask one of my colleague. He gave like you can use correlation, you can use different methods. Okay, then I come into Google to search about correlations and other algorithms that we have. We already have it, but actually we don't know. As IT teacher, we don't know how to create a connection between mathematics and programming. So once we combine and working together, really we can give new innovations.
Yes, sir. How the machine learning concept be used in research?
Any research you can apply machine learning. Okay, for example, mathematical research. Mathematics is purely result oriented. You can give the results. Mathematically you have to prove it. Okay, but when you come to real model, when you come to real practical model, then you need some changes in your theoretical results according to the real model. Okay, so artificial car, without driverless car, when you take driverless car, we can theoretically prove if it happens, this is the basic assumption, and if the assumption is correct, our result is correct, we can theoretically prove. When it comes to real model, you have to change a lot. So mathematics and IT is more related, and if they work together, they can solve any problem, any kind of problems.
Thank you, sir. Is there any packages for three-dimensional models?
Yes, ma'am. Actually, we have different, actually Matplot. Matplot is one of the library in Python. you can present, actually whatever data that I present is only data, actual data. We can also present the data in a graphical way, 2D way or 3D way. We have a separate package, matplot, separate packages there, and many more packages there you can use to present your data in 3D model. Once you present the data, after that you can go for further analysis too.
Yes, sir. Why we rescale mini-max normalization and standardization? Is there any purpose for rescaling them?
Actually, when you draw the graph with the actual data, it have different ranges. The range will be in different, every feature it may have different ranges. So when you present as a graph, some data it has a range 1 to 10, some data it may have 1 to 1000, some data it may have 1000 to 2000. So different range you cannot combine into one scale, I mean one frame. So once you make it into one frame, so your analysis, your training model will be quicker. That's why we have to scaling it. Otherwise, no need to scale. If the data is normalized, then no need to scale it.
Yes, sir. Is any other measures for association analysis other than support and confidence?
Actually, ma'am, for feature selection, we have to understand what is the correlation between features and the target feature, right? So we can apply association logic to find what are the features are more important, more contributing features to the target class. That also we can apply. And associations, we can go for a recommendation system. Okay, so when you go for recommendation analysis, for recommendation system for students, recommendation system for music, recommendation system for custom, I mean any different product to the customers, online shoppings, then we can use association analysis.
Thank you, sir.
Okay,
sir, in your presentation, why K nearest neighbor algorithm is called lazy algorithm?
Lazy, because every algorithm we have a testing and training. Testing data we have to give prior to the prediction. So first we have to give training proper to the model. So while training, the model gets logic. Okay, so we are not giving any logic. When you give the data, the model itself predict the logics. Okay, after it trained, we can give the testing data. So testing and training, there are two different phases. Okay, same like our student gets trained before go to the exam. They have to train. Once they will trained, then they will go for examination. That is testing. Okay, but K means K nearest neighbor. Okay, it's actually, it will not train. The data will not train. Once you go for testing, that time only it has to find the distance between all the data points. Finally, it will give the results. That's why it is lazy. It will not take training. It will directly go for testing.
Yes, sir. Which programming language is best for machine learning, sir?
I prefer Python, ma'am, because earlier I prefer to use, when I was doing my MPhil and PhD, I prefer to use Java. But now, after seeing a lot of advancements in Python, I recommend Python. Python is the best language you can go in any extent.
Thank you, sir. Is there any queries from the participants?
Hello. Can you hear me?
Yes, sir. Yes, sir.
I have a small doubt. When you look at that artificial intelligence, machine learning is a subset of deep learning. Is it true?
Sir, actually, deep learning is a subset of machine learning. Machine learning is a broad, and inside that we have a deep learning.
But that is why I have a little bit doubt. Normally, people are saying that these are two different objects. They are doing their own works. It's no way connected with deep learning.
No,
And
it's not like that. It's not like that. Basic algorithms are same. Only we have to implement in a neural network form. Okay, we have a different layers to filter our results. Finally, we'll get the consolidated result. That is by a neural network. So for that, we have a deep learning.
But it's machine learning. It's only for structured data. It's unstructured data for deep learning.
It's not like that, sir. We can data and the model that we choose, it's based on our need. Okay, so if you want to process any unstructured data, you can process. We have a tool to process those data, but preferably we have to format our data before we process it. That is important. We can do both structured and unstructured data. Okay, both machine learning and deep learning. It's based on our requirements. Only the coding part is a bit of complex when you do unstructured data.
Thank you.
Thanks.
Thank you so much, sir, by exemplary explaining all the questions patiently.
Welcome. Welcome.
Praise the Lord. Give thanks to the Lord, for he is good. His love endures forever. Psalms chapter 106, verse 1. Thankfulness is the beginning of gratitude. Gratitude is the completion of thankfulness. My deep sense of gratitude to our resource person, Dr. A. Salim Raja, for being kind enough. Your words of knowledge really engrossed us. Your comprehensive presentation. Thank you, sir, for this informative session. Once again, I thank you one and all. Thank you all. Tomorrow, we will meet for 4th day faculty development program by 5 p.m. Thank you all.
Ma'am, one request, ma'am. I will forward the PPT to you just to share to everyone.
Yes, sir. Thank you, sir.